Guten Morgen for those listening in the Morgan. For everyone else, Guten Tag. This is Mike Sturkel of the group Live for Your Data. Joey gave the in-class portion, so I will be doing the online. So this is Reducing Networking Engineering Skill Gap. This is just a quick comic on network engineering, another one on network engineering. So we asked 3 questions that kind of focus our research, which is why is there a network engineering skill gap? How can we reduce the gap? And does change technology make the engineering skill gap a temporary problem? So what skill gap are we talking about? So this example is one that Joe experienced in his workplace where they lost a veteran of 15 years. They put out a requisition, they got 300 applicants. Less than 10% were qualified or even qualified enough to be considered. Of the 20, there was only 3 who were interviewed, so 1% of the initial applicants were qualified enough to be interviewed, and really the only potential candidate, while the most qualified, was really still underqualified for the position and had to really just be thrown in to sink or swim. So the outputs of this semester were, these are 3 main outputs. We did a literature review that covered 25 sources, that covered many different topics I'll go into a little bit later. We developed the simulation-based curriculum using the software Cisco VRL, and then we did a 24-page paper really going more in depth into the topic. So the research methods we used for this was we chose qualitative. Our population managers from network engineers, academia, and businesses. We collect data from text-based sources, and we reviewed the research, off-the-shelf software and simulators, and future technology to kind of see how they applied to the skill gap. Now, I kind of pulled 3 bigger areas that we talked about in the literature review, put them up here. So one area was the employability. It kind of discusses that there is a mismatch in what businesses expect from students who are coming in and what kind of is being taught, and really the expectation of what students think they need to know, which is really more discipline specific, and what business want, which is really more general skills such as communication and writing that maybe are not focused on as much as they would like. And even to the point where there's actually a course made at USF where they partner directly with industry to see what industry wants or needs a student to know when they come into the field to revolve the course around that. Gamification visualization showed groups who made network training games or network training environments where they could teach concepts in a way that wasn't just reading the concepts on a piece of paper. And then the kind of last section was, does the simulation training work, and a reason why. And the reason why was motivation, that simulation training increased the motivation of students who used it, because you could redo a level, you could do it again and again. It's kind of like a safe space to make mistakes, and that this kind of helped them to want to keep learning and keep trying the material. Now, in the paper, we discussed kind of some reasons for the gap, and then really some of what training could we do that helped this skill gap. And some we looked at was mentoring, some we looked at teaching entry level. All people enter the same base knowledge, moving up to more advanced concepts to make sure everyone's the same baseline, to teaching very specific skills, which is really kind of what the certification process is from Cisco and Juniper. And then into, can we increase the numbers of people coming in the field through maybe expos that shows the career, what you can do as a network engineer. And then looked into huge technologies, mainly being software-defined networking. That does this technology, how does it affect the gap, and it would kind of show that it doesn't really affect the gap in terms of it's a different skill set. So those who need to learn software-defined networking don't need to know the older stuff. So if you're just talking about SDN now, this new technology, there's no skill gap because you're learning these concepts, but those currently in the current skill set that need to move to this software-defined networking skill set now need to be taught these new concepts, and we kind of go in the methods used to teach new employees could also be used to teach newer concepts to those who are in the field as well, and not just new to the field. And that how that SDN is not helping the skill gap, it's not making it better because it's creating its own paradigm that needs to be learned. And the simulation curriculum we went over is the Cisco VRL, just a virtual internet routing lab. It's a pretty processor intensive unit. It's not portable right now, but based on what we look at, it was the best one to use for training the concepts that we wanted to. I'm going to briefly go over it. This is here's an overview of the training environment. Here's the workspace. These are the tools. You can see you have routers and switches you can drop in to make your network, your project list, your interface to it, terminal where you enter commands, an example of a layout, virtual device list, just so you can configure your VLAN. Now, here's one of 3 labs that's created. This lab is just a basic one about you have to figure connectivity between C1 and C2. Lab 2, we get a little more advanced where we want to go from C2 to C3. As you can see, it's now that size, approximately double the size of the other one. Then lab 3 is kind of the capstone where you gotta troubleshoot as well as reconfigure to make sure communication happens. Going back to the presentation, this was actually used by Joey and his team to training purposes to show that it was a viable solution for training concepts. And one of the big reasons for it being viable is kind of how the general concept of the virtual space, and it's a safe space to practice. You can make mistakes, you can break your network, you can do all kinds of crazy things and not affect anyone. You're not affecting your actual real life network that's being used. You're not causing emails to not make it, not causing people to not be able to transfer files. And not only for training, but also you can make new implementations of a network in this environment to test to make sure you didn't miss anything, to make sure that the concepts you drew up actually work out as you thought, or there are ways to actually streamline your implementation. And this saves time and money when going to actually test and then make the actual physical installation. Now, it's kind of the main results of the semester that there is unfortunately, the curriculum at the university level and the certifications don't really keep pace with changing technology. It just takes too much time for them to change that. Sometimes you're teaching older concepts when newer ones are being used in industry. Simulation is a viable means to train network engineering principles. It was shown by multiple groups that it can be used, and can be used effectively to do this, and even more so than traditional methods, even for areas such as Cisco courses. We're adding more practical simulation-based lessons, improved the knowledge transfer, and that SDN essentially makes it obsolete in a sense that you have a new skill set to learn for it, not having to use old networking concepts. And this is kind of briefly summarize some of the stuff we kind of went over about why simulation is good for learning, and it just increases the motivation, gamification, improves learning. It can make mundane tasks more fun. It can make just learning more fun as you add maybe little goals into the level to give little in-game rewards. And we saw that mentoring improves learning as well, so that's definitely a concept that is a viable way to train, and that combined with simulation can be an effective way to quickly bring up a green engineer to a more seasoned one. And the simulation is some abstract techniques, maybe in a more tangible ways. You can see, you can mess with it, you can break stuff to really see why changing maybe a link weight does this to a network, why using the shortest path first may not be the best way, or being able to put in redundant paths into a network to see how data flows. Now, this was a lot. It's a big topic. It's a huge scope that we tried to tackle. And even though we put 30 plus pages down, there's many more we could have put. And working it from two different aspects in terms of different people having their takes on it, we had to come together and really make sure everything flowed and that we kept to the scope and didn't let scope creep, add more topics than we needed. And we even had to cut down from what we had because we wanted to make sure we were focusing our paper, not letting it spiral out of control. But it easily could have been expanded to double, triple the amount of pages we wrote just due to not having maybe the time to go into as depth as we need, or that some areas need to be fleshed out more just based on further research. And this goes into what could we do with more time. With one more semester, we'd actually want to expand our training that was made in the Cisco VRL and then actually implement it in a pilot study to see, does it work? What do we need to change? Does training a novice or an expert mean that we need to not only bring different material, but present a different way to, or give a different way to present the material to them because of their difference in skill level? And then with 2 semesters, with that second semester, we'd be able to flesh out the analysis more, do interviews with the network engineers, find their insights into the skill gap, see what they have experienced. Do their experience agree with what we've seen in the literature, what we've seen in our own experiences, and kind of the ways we're trying to correct it? And then through all that, we've expanded our paper, but then we need to use that and the results from the study to refine it into the areas that we need to focus on and edit it down and really just make it nice, streamlined, and clarified so we're answering the topics at hand, put in as much depth as they require, which we may not have been able to due to the limited time frame of 1 semester. Well, that's all I had. Any questions for me? Since you don't have any, I have a question for you, which is, why aren't there more ports considering so much larger on the inside? Just a little Doctor Who TARDIS joke for those who are fans of the show. I know Dr. Carter is, and maybe you are too. Well, goodbye for now. Thanks for listening.